Hello and welcome to this learning video. In this learning video, we are going to take a variety of problem which is different from the problem that we have taken. Okay, so here as you can see, this problem says find the Fourier transform of f of x and f of x take values 1 and 0 for mod of x less than 1 and for mod of x greater than 1. And then we have to find out this. So forget about this. First of all, we should concentrate on the first part, that is find out the Fourier transform of the function. So let me tell you one thing, if the function is even function, then the problem is of Fourier cosine transform. Okay, so that you can write as a remark, if f of x is an even function, then Fourier transform is nothing but the Fourier cosine transform. If you want, I can write it and then we can continue with that. So you can write since f of x is an even function. I hope the definition of even function is clear to you. If this is my function f of x, so this function is even, we can say that this function is even if I replace x by minus x, I must get f of x. Then we call this function f of x to be even. That is the definition. But here as you can see, the functions takes the constant value. So constant function is an even function, right? Therefore, so what I was writing, since f of x is an even function, therefore Fourier transform of f of x, Fourier transform of f of x implies Fourier cosine transform. Simple. So this I have used. Now let us start with the Fourier transform definition and substitute the function, right? So we know that, now I am very habitual of writing this. We know that, what we know? We know that the Fourier cosine transform, of f of x is what is that? Fourier cosine transform of f of x, which we write it as f c bar of s, that is, what is it, under root 2 by pi integration 0 to infinity f of x into cos of sx dx. So you can check it once, that Fourier cosine transform of the function is under root 2 by pi integral 0 to infinity f of x into cos sx dx, right? Now you have the function. Now you just look at the function. Now if you look at the function, it has values 0 and 1. So what I am going to do here is, I will break this interval 0 to infinity as 0 to 1, then 1 to infinity. Okay, so let me write this one as 2 by pi, and here I am breaking. Why I am breaking? Because the values are given, two values are given, that's why. So this is 0 to 1 f of x into cos sx dx plus integration 1 to infinity f of x into cos sx dx. Now some may be having doubts like why only you are breaking like 0 to 1 and 1 to infinity. If it is like 2, 0 to 2, 2 to infinity. Okay, likewise. If it is a, 0 to a to infinity. So this is under root 2 by pi integration 0 to 1. Integration 0 to 1 means mod of x less than 1. So its value is 1. So I will write it as integration 0 to 1 f of x for this is 1 into cos sx dx. And what about this integration 1 to infinity? What is f of x for x greater than 1? 0. So 0 into cos of sx dx. Okay, second integral is vanishes. The first integral will give you something, and that would be under root 2 by pi. What is integration of cos? Is sine sx divided by the coefficient of x, limit 0 to 1. Simple. So at last I will be getting Fourier cosine transform of s comes out to be under root 2 by pi. Okay, what is this? This is when you substitute upper limit. So this is sine s into 1 upon s, and sine 0 is 0, so it will gives you only sine s upon s. Okay, those who are getting difficulty, let me write down for them 0 under root 2 by pi, then it is sine, put x is equal to 1, sine s upon s minus sine 0 upon s. So sine 0 is 0, this is 0, we will remain with this. Simple. Now, so first part is over. We have found out the Fourier transform of this. Okay, now we need to get this result, and to get this result we'll make use of the inverse Fourier cosine transform. Okay, so now actually I can make use of it here only. Now the Fourier inverse cosine now the inverse Fourier cosine transform of f of x is, what is it? Fourier inverse of, okay, so it is like Fourier cosine inverse of, not f of x, I'm so sorry, of fs of fc of s. Okay, so Fourier inverse transform of fc inverse of fc of s is nothing but f of x, and this is under root 2 by pi integral 0 to infinity. This is Fourier cosine transform of function, and then cos sx dx. Yeah, that's correct. Okay, now you have this value, you can just substitute it. So this is f of x, this implies f of x is equal to under root 2 by pi integration 0 to infinity. What is this value? This value is this, under root 2 by pi into sine s upon s into cos sx dx. Simple. Now what you can do, you can just take this to the outside of the integration. So your f of x will look like, what is my f of x? Okay, so I will write f of x, this become 2 by pi, and this is integration 0 to infinity. What about this? This is sine s upon s into cos x, sine s upon s into cos sx dx. Okay, now this is on the left hand side, I am having f of x. What is f of x? This, so I can write it like f of x is equal to 1 0 mod of x less than 1 mod of x greater than 1, and this is same as this. So now what should I do now here? So I will substitute. Now as you can see in the answer, I am having sine x upon x. Okay, so what I will do is I will first of all put uh, x is equal to 0, okay, because I am having in the integral we have only sine function, no cos is required. So to get the required result, I am just first of all I will put x is equal to 0. So put x is equal to 0, we get, now the moment I put x is equal to 0, so this will be so this two values of f of x are there. So for x is equal to 0, we will be getting 1, okay, and this is not valid because I'm putting x is equal to 0. So my f of x will gives you 1 is equal to 2 by pi integration 0 to infinity sine s upon s cos 0 dx. And what is cos 0? Cos 0 is 1. So we remain with, this is pi by 2 integration pi by 2 is equal to integration 0 to infinity sine s upon s ds. Oh, shit. So please make a correction here. In the inverse Fourier transform it should be ds, not x. Okay. So take care of these things. Ds. Now you can put s is equal to x, and why we are substituting it? Because we want this problem. Okay. Or if you do not want to put here, you can just make use of the property, okay, property of definite integration. So you can directly write that is pi by 2 is equal to integration 0 to infinity sine x upon x dx by property of definite integration. Simple, okay. So you can write, therefore integration 0 to infinity sine x upon x dx is equal to pi by 2. So this is the result that we wanted to prove. So I hope the things that has been discussed in this video lecture are clear to you. So thank you for watching this learning video and keep learning. Thank you.